Good afternoon and welcome to Dartmouth College and our Leading Voices in Energy, Sustainability, and Security series. This summer's Leading Voices program is directed by Professor Andy Friedland, the Richard and Jane Pearl Professor in Environmental Studies. My name is Carolina Caviaca, and I teach architectural design and sustainability classes here at the college. This week, I had the great opportunity to teach the Tuesday class in Professor Friedland's course that is part of this lecture series. This is the 5th week in the Leading Voices series, and it is a great privilege to have William McDonough, class of 1973, to discuss sustainable design. Next week, on Thursday at the same time and place, our speaker will be Seamus McGraw, author of The End of Country, Dispatches from the Fracking Zone. So we'll hear about fracking next week. I hope you all can make it back here next week at the same time, same place. This afternoon, Bill McDonough, who is an internationally recognized expert in sustainable design and co-author of the Upcycle, Designing for Abundance, joins us to continue our discussion of energy, sustainability, and security. Bill was born in Hong Kong and attended Dartmouth and earned his Master of Architecture degree at Yale University. In 1981, he founded his architectural practice, and his first major commission in 1984 was the Environmental Defense Fund headquarters. That building's requirement of good air quality in the structure exposed him to the need for sustainable design. Bill's architecture practice, William McDonough and Partners, operates in Charlottesville, Virginia, and San Francisco, California. In 1994, he was appointed as the Dean of the School of Architecture at the University of Virginia. He relinquished this position in 1999 to focus on expanding his professional practice. He's also co-founder of McDonough Braungart Design Chemistry, based in Charlottesville, and is chairman of McDonough Advisors, which provides high-level consulting to companies, organizations, and governments around the world, among many other things. A number of large corporate projects for the Gap, Nike, and Herman Miller led to his commission for a 20-year, $2 billion legendary River Rouge plant in Dearborn, Michigan, for Ford Motor Company. This project included rolling out the world's largest 1.1 million square foot green living roof in October of 2002. He's worked on many, many innovative architectural projects, including the Lewis Center at Oberlin College and NASA's space station Earth. In 1996, Bill became the first and only individual recipient of the Presidential Award for Sustainable Development. In 2002, he co-authored with chemist Michael Braungart, Cradle to Cradle, Remaking the Way We Make Things. I hope you've all read that. In 2004, he received a National Design Award for Environmental Design from the Smithsonian Cooper Hewitt National Design Museum, and he's also a senior fellow of the Design Futures Council. Over the years, Bill has very generously visited some of my classes at Dartmouth, including my engineering classes and my architectural design classes. And now that his son Drew has been accepted to Dartmouth to start next fall, we hope to see a lot more of him here on campus. In his design work and writing, Bill gives the inspiring message that we can design materials, systems, companies, products, buildings, and communities that continuously improve over time. Please join me in welcoming William McDonough.
Thank you, Carol. Can you hear me? Is that working? Great. Hi, everybody. It's a privilege to be here because I'm part of the Dartmouth family. And as Carol mentioned, my son will be coming here, which is a great privilege, as you can imagine, for a father to imagine his son wanting to be in this place and getting here. Here he comes. Sorry, Drew. Can't help it. But I also want to just say I have a couple other connections here that I would like to say before I begin that are very heartwarming and important to me. One is that my best friend from Dartmouth, Mac Root, is here. And Mac and I are going to be working together on some new things, and that's a great connection. Also, I'd like to thank Simon Pierce for coming, because Simon was my first client in Ireland. So thank you. It's great to see people after all these years. So what I'd like to talk about now is next. I think what's next is what's next. And it amazes me that we design things today without even thinking about what's next in the design of what's now. And I was at a conference with 150 textile makers at a Future of Textiles conference, and I was keynoting it at the end. And I got up and I said, you know, I've asked everybody in this program, all these fabrics from around the world, amazing things, you know, clothing that has batteries for people to charge their stuff while they walk around. We had new age clothing that shows your emotions with color. We've had, you know, it was amazing how many things are going on. We had stem cell clothing that grows on your skin. I mean, it was quite something. And at the end of it, I said to the people, the 150 people doing this stuff, I said, so what's next? And they all said, well, next year I'm coming back with one that can glow pink when you think like this, or whatever. And I said, no, what's next for what you just showed us now? Every single piece of cloth that had been shown in that program was toxic nonsense. Every single one. Nobody had asked, what's next for this thing I just did? What they wanted to talk about was next year's fashion. So, I think it's a great opportunity for us to have some fun with what is next in what's now. So I will show you buildings. We design office buildings as housing of the future, so that if we don't need them for this, they become that. We look at buildings made of steel versus concrete because if they ever have to be torn down, the steel is fungible. It's a commodity rising in price, and the concrete becomes aggregate. And so we can actually look at these materials as having passports, as Michael Braungart puts it. And we can look at the whole concept of endless resourcefulness of things, of energy, and people. And if that's not why we're here, then why are we here? And if that's not an occasion to which we can rise, then what occasion are we sinking to? So I want to talk about then, now, next in terms of what the sustainability universe has looked like in our culture. And I'd like to just reflect on the fact that I'm actually not that interested in sustainability. If I asked you what's your relationship to your wife or husband, and you said, sustainable, I'd say, I'm sorry. It sounds really boring, okay? We're here to celebrate life and to celebrate the children as we go forward. So what I want to talk about today is design innovation for the ecological century. Because if we look at the, the fact, I'm coming here from Charlottesville, Virginia. Drew was born in a house designed by Thomas Jefferson. When you live in a house designed by Jefferson, you realize that he saw himself as a designer. He designed your house, but he also designed his tombstone. And on his tombstone, he only recorded the things he designed. It was his last design, and it says, Thomas Jefferson, author of the Declaration of American Independence, the Statute of Virginia for Religious Freedom, and father of the University of Virginia. Anything missing? Can you imagine being president of the United States twice? It's not important enough to put on your tombstone. He's not recording his jobs, his activities. He's recording his legacies. He's recording what he designed. And design is the first signal of human intention. And if we look at the 1700s and the kinds of things that are inherent in the Declaration of Independence for what it was, even though it only applied to 6% of the American population, white landowning Protestant males at the time, still, it's the signal of human rights. And they were called natural rights, as we remember, during the Enlightenment. Natural rights, human rights, okay, the idea of rights. And then we see the destruction of feudalism. And then in the 1800s, after Adam Smith publishes The Wealth of Nations, same year as Declaration of Independence, we see the rise of the economy and markets. And then we see capitalism and communism, the social market economy, neither of which was good for the environment, because at the end of the 1800s, we discover fossil fuels. And then the 1900s, guess what happens? We have a social market economy, and we trash the joint. The American century. We invent pollution. We toxify rivers, the atmosphere. And then at the end of the 1900s, we have sustainability. And what is that? Oh, it's eco-efficiency in terms of what we see. So the real question is, the next century goes from Equity, 1700s. Economy, 1800s. 1900s, we trashed the joint. What is next? Next is the ecological century, and the question that is fundamental, I think, relates to our values, not our metrics. We're not here to benchmark and measure against our less badness. We're here to talk about what we want and moving forward. So the question is one of values. And so here's the question that we ask. How can we love all the children of all species for all time? It's not just our children, it's not just our species, and it's not just for now. If you ask that question by design, when you're doing something, interesting things happen. So in 1992, for the Earth Summit, the German government hired me to design the Hanover Principles Guidelines for the World's Fair for the year 2000, which were design principles for sustainability, and I gave those to the World Urban Summit in Curitiba, Brazil, at the Earth Summit in Brazil. 2002, Michael and I wrote Cradle to Cradle, and recently a set of evocations based on that. This is me and Michael at the Earth Summit. This is a long time ago. But at the Earth Summit, what they talked about with the Business Council for Sustainable Development, later the World Business Council, was only ecoefficiency. And this is the term they coined at the time. This is from their site. But look at it. It's the concept refers to creating more value with less impact. Less impact, like impact's okay, and it's negative, so we need to do less of it, and is that good? You see, I want to ask this a question on a polemical basis. Is being less bad being good? You see, this is not math. It's not less and bad are negative numbers, you multiply them, you get a positive. No. Bad is a human value. Less is a relationship. So being less bad is being bad, just less so. So, okay, so we accept that as a concept, and idea would be produce goods and services using fewer, less, generating less waste, as if waste and pollution are inevitable. See, in nature, there is no such thing as waste. One thing's waste, another thing's food. See? So what if we eliminate the concept of waste? Research has shown that it measures, pay big dividends in cost saving. Does this mean don't do it? Of course not. Of course you do this. But this is demand-side management. What I'm interested in is something slightly different. You see, because the problem to the future generations and what we tell people is when we say it's time for us to reduce our carbon by 20% by 2020, if that's the message of eco-efficiency that we're going to give our children, what are we saying to them? All these people out there saying, my goal is 0. Really? It's better if we're not here. Is that what you're saying? Is the population problem? Is that a child born in India? It's better if it's 0? Is that a message to tell a child? We wish you weren't here? Is that it? Or you're a population problem? If a child is born and seen as a population problem, then human rights cease to exist. Okay? So the question becomes, how do we celebrate this? And if all we can say is what we don't want to be, if that's all we have, that would be like getting in a cab out of here and I went, quick, I'm not going to the airport. I mean, let's tell people what we don't want to be. That's it? That's all we got? Really? So, when we look at these charts, it's kind of insane, really. What would this be like in a conventional commercial situation? Imagine you go into a store and there's a jar with brown goop and it says, not peanut butter. Would you buy this? That's what we're not. Or there's another one I love, which is free of. Here, peanut butter free of plutonium. Like, we worked with an ice cream company well known to you, and they wanted a chlorine-free package. And we said, well, that's all very nice. You want to be chlorine-free, but what about the toxic inks and the plasticizers and the polymers in your paper that can't be recycled? And now your carton is chlorine-free, but that's it, but still all these other things. If all you want to do is be free of, why don't we just advertise plutonium-free ice cream? It doesn't cost you anything. You're selling what you're not. Am I the only one who thinks this is odd? All right. So anyway, so let's talk about the difference between efficiency and effectiveness. I was born in Tokyo, actually. And so I studied Deming as I grew up, and I saw total quality management coming toward Toyota and so on. And Deming was a statistician sent by the War Department during the Second World War to factories to watch the women. after the men left and went to war. And the women outperformed the men by about 40%. And he was keeping statistical records of all this. And he discovered they all sat in circles, they talked to each other, they shared the work, they had no exhortations, they had no inspections, they had no hierarchies, they had no quotas. The men had produced like 1,000 artillery shells a day in the factory, and the women started with 50, and they worked their way up to 1,400, and they were perfect. And the men had like 25 rejects a day and inspections everywhere and stuff like that, and quotas. The women just made as many as they could make that were perfect. So he kept track of this, and the men came back after the war, and he said, you should see what the women did while you were gone. And they said, excuse me, we're hierarchical, we're inspection-based, we won the war, get out of here. So he went to Japan, the rest is history. So he gets to Japan, he starts working with them on sitting in circles, whatever. And so now we have the Toyota production system. But the problem is that he was a statistician, and it was called total quality management. And the problem is, it's not total quality management, it's total quantity management, because he's a statistician, you see, it's metrics. And its sharpest tool is 6 Sigma, perfection. But they were making armaments. So the question of what are we making was they were making something that was about their survival. But if we stop and think about it, if you're making something that is the wrong thing, and you're doing it perfectly, you're perfectly wrong. See? So is efficiency a good? No, it's a tool. You see, what if you're a Nazi and you're efficient? You're worse. See? So the question isn't, am I being efficient? Am I doing it the right way? That's the second question. The first question is, am I doing the right thing? So Peter Drucker pointed out in his book, The Effective Executive, 1984, he said, it's a manager's job to do something the right way, but it's the executive's job to do the right thing. See, if you're making Hummers in a market looking for Priuses, and you're making them perfectly, you're still out of business, see? The perfectly wrong product. All right. So the question becomes, can we be effective first and then efficient like that? But it is good to be efficient, it's fun. But in the Hanover Principles, you'll notice that I wrote 9 principles, and they start with insisting on the rights of humanity and nature to coexist, recognize interdependence, respect relationships between spirit and matter. When I work with indigenous people, they all look at this and go, you know, there's only one that matters. It's that one. Isn't that interesting? And then be responsible, which is, you know, worry about unintended consequences and know that you're doing something that affects the world. Create safe objects of long-term value. Why, you know, think of the opposite. And eliminate the concept of waste. This is important. Not reduce waste, minimize waste, avoid, minimize. It's eliminate the concept. Rely on natural energy flows. Understand the limitation. Be humble. It took us 5,000 years as a species to put wheels on our luggage. We're not that smart, really. Okay? And it was only 2, now we got 4. Oh, big idea. So, anyway, understand the limitations, be humble, and then seek constant improvement by the sharing of knowledge. Here we are today. Now, what Michael and I have put forward in Cradle to Cradle is fundamental, because we're saying that if you look at the history of the planet, we've had biological nutrition in cycles and metabolism. And in the last 5,000 years, we started making things that really could be seen as having a metabolism we call the technical metabolism. So we can design into them. When I have a television set, do you want to own 4,360 chemicals, many of which are toxic? Is that what you want? And what if I sell it to you, I say, here, take this home, it's 4,360 chemicals, highly toxic, put it in front of your children and encourage them to play with it. You know, do you want to own these chemicals? No. What you want to do is watch TV. See, so we call these products of service. And why couldn't we design them to be infinitely reusable by humans without toxifying the biosphere? See? So we designed systems that allow these electronics to be disassembled safely so all the materials can be reused by humans without contaminating the biosphere. As we look at the architecture, this is a building I designed for the Gap in 1992, and it's a meadow of the ancient grasses. We had to go to the federal government to get permission to collect seeds from ancient grasslands, because you can't buy them in a nursery. And so we did the entire roof with the ancient grasses, so a bird flying overhead would go, oh, it's our people, they're back. So that's what we did. Now it's a nursery that sells native seeds. So it's a business on the roof that makes money. So, and we did the seeds from this went to do the California Academy of Sciences for Renzo. Piano. How exciting. But anyway, the question I was asking was, what if I could make buildings like trees? I started asking this in 1989 on a daycare center in Frankfurt, where I wanted the children to operate the building. And so I had cranks and shutters and solar, and the kids could come in and wake up the building in the morning and put it to bed at night. And the engineers in Germany said, you can't do that. You can't have children operating a building. I said, why not? They said, well, if they don't open the window, they get too hot. I go, well, they're going to open the window. Are your children brain dead? And he was like, why can't we have children operate a building? Well, if they forget to do this, that. I said, wait a second. I brought in the teachers, and the teachers looked at the engineers and said, listen, you got to understand something. Our job in a daycare center is to figure out things for the kids to do. So if they want to wake up the building, put it to bed at night, what's the problem here? And but then I noticed that the kids were eating the building while they were having this argument. And I'm going, I need an ecotoxicologist because they're eating the building. They have their mouths on everything. And so that's when I started really worrying about the materials down to the parts per billion. But in the process, I designed that building to be a building like a tree. It would be powered by renewable energy. It had roots in its geothermal system. It had gardens on the roof for food. It had a place for the parents to wait and do laundry for free while they waited for kids. It's part of the community. And the idea was fecundity. And so what if a building emitted oxygen, sequestered carbon, fixed nitrogen, accrued solar energy, created food, fuel, clean water, provide habitat, create microclimates, changes color, self-replicate? That's pretty tough, but hey, give it a shot. So anyway, what if a building could be like a tree? And this came out of being here at this institution, and I'll explain that in a minute. So when Bill Ford asked me to do the roof, he did it in public at a public press conference. I had no idea why I was there. I was just asked by his office to be there, and they were talking about exhaust manifolds and intakes out of recycled nylon or something. And all of a sudden, in the middle of it, he leaves the script, and he has me sitting with senior management. He goes, and today we're going to announce the renovation of the River Rouge, my great-grandfather's center of the first industrial revolution, 2,500 acres. And we're going to ask Bill McDonough to do it, and he's right there. First I heard of it. And afterwards, I said, what were you doing? And he said, if I had asked for permission, I never would have gotten it because you've never done an auto plant before. So we better go produce some shareholder value or we're both toast. So off we went. And we built this on the same schedule and budget, opened on their 100th birthday, and it was the world's largest green roof, as we mentioned. But here's the magic. This is how this works. Okay? The tools that we use are, oh, that's a roof. Oh, those are killdeer eggs. Oh, that was 5 days after the roof was put down. Okay? And why wouldn't we have roofs like this? Why wouldn't we? But here's, when people say, Bill, how do you get to do this stuff? This is how I do it, okay? We looked at the site and we looked at their books and posted on their books as a contingent liability, a responsible company, was $48 million to meet the Clean Water Act with 3 chemical treatment plants, 4 miles of pipes, and 70 auto workers standing around piles of chemicals praying it doesn't rain. And instead of that, that was already posted to be spent, engineered, ready to go. Our whole system was 13. We saved Ford $35 million day one, CapEx, capital cost. The Ford Taurus was coming out of Chicago to 4% margin. This is the same as walking into the board, which I only had a minute and a half. And when I walked in, Bill Ford said, take twice as long as they gave you. I said, they gave me a minute and a half. He went, oh boy. So I said, I don't need it. A minute and a half's fine. So I said, first 30 seconds, I'll take. This project's for the birds. And that is true. And these are fiduciaries in the car business, running a big car company. And I said, so for my other minute, you're fiduciaries in the car business, so I better talk about money and cars. So here's the bottom line. We're going to save you $35 million CapEx with a new kind of engineering. And with the Ford Taurus coming out of Chicago at a 4% margin, this is the equivalent of me walking in here and giving you an order for $900 million worth of cars. Approved. That's how you do this. It's not just a good idea. The world got better. Herman Miller, the factory I did where they make the Aeron chair now, this factory cost $15 million, 300,000 square feet, $50 a square foot. The 350 people who moved here from a dark factory increased production from 250 million a year to 350, and all they did was move. Right? $100 million more production, take out the material cost, $60 million. They made $40 million a year more profit. Top line, bottom line, right? Top line 100, bottom line 40, and all they did was move. So Herman Miller says the building pays for itself every 4.5 months. It's not energy savings produce 10% return. The building pays for itself entirely every 4.5 months. Okay? This is the difference between using values to drive your behavior than metrics. So instead of quantification and just doing metrics and benchmarking against existing behaviors and being less bad, we like to start with the quality questions of what do we want to do? What are our values? How about all the children of all species for all time? And then we move to the principles like the Hanover principles. Then we set our goals. See, now engineers are famously people who know more and more about less and less until they know everything about nothing. And architects are famously knowing less and less about more and more until we know nothing about everything. So between us and the engineers, we got a lot of space. And so the question is, how do you approach a problem? And you can approach it from both ends. I obviously have to prove metrics so I don't get to do my work, but I can start with values to drive the design. So in 1993, I was hired by Design Techs to design a collection of fabrics, and I said, I'll design what they look like, but I also have to design what they are. So we went to a mill in Switzerland and working with the chemists, we looked at 8,000 chemicals in the textile industry and discovered that we wanted to eliminate using filters of no more mutagenicity, genetic mutation, carcinogenicity, cancer, teratogenicity, birth defects, endocrine disruption, and so on. We had to eliminate 7,962. So we had 38 chemicals. We did the entire fabric collection with 38 chemicals. It saved 20% of the cost. But what was also interesting is the trimmings of the cloth before we got there had been declared as hazardous waste by the Swiss government, and they couldn't bury or burn them in Switzerland anymore. They had to ship them to Spain. Now, you've hit the wall of the first industrial revolution when your trimmings are declared hazardous waste, but you can sell what's in the middle. Obviously, the most efficient thing to do is just send the product to the customer, let them trim it. It's cheaper. But you know, if your trimmings are hazardous waste, your product's hazardous waste, obviously. So by changing the chemistry and saving all the money on the hazardous materials and the inventory control, because we went from 249 SKUs to 38 managed in the process chemicals, the textile became mulch for the local garden club. And now we have strawberries coming out of it. And it's become the fabric of choice by Airbus 380 because it's the safest fabric in the world. You can sit on it, you can breathe the fibers. In fact, if you have at 40,000 feet with extreme fiber deficiency emergency, you could safely eat your chair. Right? So then I worked on carpets for Warren Buffett, and we started looking at fabric carpets where we use polyolefin and nylon 6 and make carpets that are infinitely reusable. And instead of PVC, there are people that claim ecological credit for their PVC carpet, which produces dioxins and so on, because they use recycled content, but it's all toxic. So do we have to choose between this? So we designed the carpet so that the top is nylon 6 back to caprolactam, and the base is a thermoplastic polyolefin. So the carpet basically is a company is storing its materials on its customers' floors, which becomes a different business relationship because now you're a product of service. You're providing flooring services, in effect. And the molecules get moved back and forth in a business relationship that's symbiotic. The same with furniture. For Herman Miller Steelcase, we do their materials protocols. This is the Think chair, the Mirror chair, the first Cradle certified chair. These chairs are designed to come apart with tools you'd find in a kitchen drawer in 5 minutes. And so this isn't about closed loops, because if this chair ends up in Mexico City and 15 years from now gets thrown out, it's not going to go back to Michigan, right? But we know that's aluminum, and we know that's steel, and we know that's polycarbonate, we know that's polyester, and they're marked, and you can put them back into material flows, so we can have intelligent material pooling on a global basis. So in 1998, I got asked by President Clinton to head for the US, the China-US Center for Sustainable Development. My counterpart in China was Deng Xiaoping's daughter, who had run the Earth Summit for China. And so we've been working on bringing these issues to China for all these years. Now, when we wrote Cradle to Cradle, what we posited was waste equals food, use current solar income, and respect diversity. And as you'll see in the new book, we've changed this. We've changed waste equals food to simply everything is food. Because if you use the word waste, you think there's such a thing as waste. If I said, don't think of a pink elephant, You can't help it, right? So we don't even use the word waste anymore. It's all nutrients. And food for thought, food for technology, food for biology. We use clean energy. You'd be amazed what we're seeing in advances in clean energy that aren't even solar driven. Quite interesting. And then instead of respect diversity, we realized that you could respect diversity while it dies. So as we watch biodiversity be destroyed, we can respect it as we watch the monarch butterfly habitats collapse from 29 acres to 2.9. And we can respect the butterflies as they go away. But what we really want to do is celebrate them and restore them by design. So being less bad is not being good was part of the message of Cradle to Cradle. And what we looked at is if we're going to go to zero and we just want to show how we're reducing our badness, that's interesting. But if all we're going to do is put bad on top of the line, really? Anybody here do business? How many people like charts that go down to the right? Okay. The expense accountant, maybe. That's it. Right? We like charts that go up to the right. We like growth. We like celebration. Our children, they grow. So we've decided we'll just put that below the line. And yeah, we'll get rid of that stuff. And our goal is zero, fine. And then we'll just put on top what we want. And now we've got a strategy, right? So let's get rid of, out with the bad, in with the good, right? It's like breathing. There it is. So what we see though, this is a current ad by a major car company from Japan. Look at this. AIM, zero emissions. You gotta be kidding, the picture of a tree. Zero emissions? Trees emit oxygen. This is ridiculous. It's absurd, it's not scientific. Thank goodness they emit. If they didn't emit, we're all dead. So our aim is zero emissions, really? Sad, don't you think? So I was asked by NASA to design the Mars station with them. And I said to the administrator, I'm sorry I can't do this. And he said, why not? I said, I can't go to the red planet until you come back to the blue one. Let's think about it. Remember Yuri Gagarin when they took him out of that capsule? First person to go to space. And they open his helmet and he looks out with these eyes this big and they say, so, Major Gagarin or Commander Gagarin, what was it like? And his answer was, it was blue. Yeah. So there it is. And when we look at the Earth, what we realize, blue is water, white is water, brown is ancient dirt, green is current photosynthesis. Okay, I'll start working this out. So I said, look, I'll do a space station with you, but how about we do one on Earth, and how about you give me this design team? Because they say here on Earth that you don't need to be a rocket scientist to do something, but what if you were? So give me the rocket scientist, let's design. So we did. So I went to the space the center at Johnson Space Center where they heard the words, Houston, we have a problem. And this was our team. And I said, great. Who did this? Is this nuclear powered? The power source is 93 million miles away. It's 8 minutes and it's wireless. Is that what's going on here? Uh-huh. You guys did that? Uh-huh. Yeah, over here. You're in charge of the energy. Cool. Great. Water. Do you guys recycle water up here? Even urine? Uh-huh. $80,000 a gallon to get water up there. $80,000 a gallon. That makes you think, right? So, sure, forward osmosis. Good, you're in charge of water, right? So, that's the design team. So there it is, we built it. It was built on a normal federal budget, ahead of schedule. This building is NASA's Advanced Research Center at Ames in California. Very easy climate to play this out in. You can grow almonds here, so this is not rocket science. But anyway, I mean, it's not like New Hampshire. I guess that's my point, you know. But anyway, they can't cut off my solar shading devices because I'm in exoskeleton, so if they want to get rid of my sunshades, they have to watch the building fall down. But in any event, this building, built on a normal federal budget, has the potential of making 120% of the energy it requires from renewable sources and purifies own water. So you can't say it's not able to be done. 120% of the energy, you know, building like a tree. It gives more than it takes. We want more of them, not to watch them be less bad. This is a project I'm doing in Amsterdam. Same thing. We're growing the food. It's going to be over 100% renewably powered. It's very exciting. And all the materials now are being cataloged against Cradle to Cradle criteria. We have a certification program. And so we have all these building materials now, and they're being deployed here as we go. So really, this is the chart that Michael and I have come up with for the Upcycle. It's essentially, can be used for products, for anything you want. These could be departments in a university, they could be all your buildings, they could be your products, they could be your molecules, whatever. And what we're saying is we have this undefined universe. And so we need to do our inventory. And then we need to put values to decide what we want to put through into the future. And so this Boolean filter in product design and cradle-to-cradle certification, this is, does it accrue in human mother's milk? Is it a mutagen, teratogen, endocrine disruptor, you know? And if you want to make that, you can't be cradle-to-cradle. Because we know how to fire retard things without bromine. We can use phosphates, we can use aluminum hydroxide, we can do all kinds of things that are relatively safe and delightful instead of toxic, and do all the things we want. We just have to decide that matters to us. And we have to be cost effective, of course, or we're not in business, you see? So that's what we do. And so 3 years ago, I was asked by Governor Schwarzenegger in California if I would turn over Cradle to Cradle to the public as a public good, so we created the new institute. And here we are with Martin Fisher from Stanford, Wendy Schmidt, who was our first chair. Her husband's Eric Schmidt from Google. This is Chad Hurley, a friend of mine who's the founder of YouTube. This is the chairman of Herman Miller, and this is Warren Buffett's representative from Berkshire Hathaway. So this is something that's starting to move. And basically we can start asking now, and it's slow, you know, because this is tough stuff, but it's very exciting. So we now have cradle-to-cradle certified products coming in. And usually it's these innovative companies like Method. These are all cradle-to-cradle certified. And we're doing their new factory. This is, Puma has just announced 36 products that are all cradle-to-cradle. So these are shoe soles that are good for the soil, things like that. Rucksacks that are infinitely reusable. And I work with Brad Pitt, a friend of mine. We're doing a project in New Orleans to build housing inspired by cradle-to-cradle. Jones Lang LaSalle, which operates 2 billion square feet of real estate, has just adopted cradle-to-cradle as a standard. For all their owners. The U.S. Green Building Council LEED program just announced recently that cradle-to-cradle has now been set as the gold standard for materials for LEED. You get 2 points if you have cradle-to-cradle materials, and so on. So in the Upcycle, we're saying everything is food. Use clean energy, celebrate diversity. So I'll just show you a couple of projects I'm working on right now that are fun for me. This is a factory I'm doing in India. The client, as a chairman, called me, a motorcycle company, and said, I need you to do a factory. I said, I can't, I'm busy with China and so on. He said, you must. I got up at 2 in the morning. I sent him this drawing. What we do is fun. Anyway, basically, I said the building is empty. Remember, in the Tao and in Zen, they'll say the value of a vessel is in its emptiness. And so this is an empty factory. It's totally clean, no ducting. I don't need any of that. And we're going to do it all with exoskeleton structure. And once I have the structure, I get free space for my solar collectors. And if I gang the trusses, I can have farming going on between. So I can have 450 people working in the building, but I can also have 350 people working on the roofs. So these solar collectors alternate with greenhouses. Because I can take the mechanical system and I can use biogas and I can make electricity, heating for the paint shop, cooling for the air conditioning. I'm running a power system, so I have 24/7 on my absorption chillers running off the exhaust of the generators, which means I can make water out of the air, about 6 million gallons a year, in a desert climate where they've now said you can't, if you take water out of the water table, you have to replace it 180%. Can you explain that, how you do that? I can't figure that out. Do you have to go rob the next watershed? I mean, huh? So we'll just take it from there. And then we use the water to grow the spinach or whatever we're growing in there, and we export the water in the spinach. We have CO2 to run the greenhouses, but we also can make oxygen in the building, so I'm working with the government to reduce the requirement for 4 air changes an hour so that I can actually produce oxygen indoors, and then I don't have to heat and cool air I don't need to and get dust out of it because I'm giving all the workers oxygen and beautiful plants to look at. And that move alone will pay for the system in 4 months. Imagine. And we're giving people fresh air and oxygen. Brad and I are doing this Make It Right program, which is something we started where the levee broke in New Orleans, and it's sort of like architectural jazz, it's improv. We have 20 different architects from around the world we're working with, including some well-known ones like Frank Gehry and so on. And we're doing houses, people can pick from them, but what I love the most, you know, other than the sort of fun of it all and this improv that's going on, is that these families, we have one woman who reported to the Clinton Global Initiative. She brought her kids, her son, her daughter. She's a single mother, hospice care worker, coming back from Texas. And she couldn't believe she'd go back to her neighborhood. She has a house, it's a $400 mortgage. Her energy bill is $25. They're all solar powered. We started a Make It Right solar company because the bids were all too high, so we started our own company. We're now the biggest solar installer in Louisiana. But what I loved is she said, my daughter wanted to be a dancer and my son wanted karate lessons. And I could never afford them. And when we came here, now I can afford them because my mortgage is affordable, my energy. She said, but there's something else you need to know. My daughter couldn't dance. And my son couldn't do karate because they both had severe asthma. They've been living in a FEMA trailer with formaldehyde. They couldn't breathe. She said, you know what it's like every morning and you wake up and your kid goes, is that what we do to kids? Is that our intention? After 4 months in their new house, she's getting dance lessons. Her asthma's gone. Make it right. So if we think about this, it's little acts that have an effect. I talked to Murray Gell-Mann at the Santa Fe Institute about chaos theory. He had discovered the quark. And he said, you know, Bill, the butterfly effect, you think you're being two-dimensional, but you're actually surrounded by massive chaos. And we need you to stay calm in there, in the eye of a hurricane. And when we think the little things make big effects, and if you think about the Monarch, look at this. Look at this. This is the collapse, okay? There's various reasons for this drama right here because of logging that still goes on. You see trees being dragged out covered with butterflies. We see Monsanto, and Monsanto is 94% of the soybean market today, crops, and it's Roundup Ready, which means there's no more milkweed. So the food of Monarchs is disappearing while we grow soybeans or corn for ethanol or I don't know what, you know. So these things are all connected, and it is a little thing has a big effect. But look at the children. The Annenberg Foundation, which we work with, created an app so that children can take smartphones and take pictures of monarchs, and it actually sends it to an app where all the monarchs are being tracked by kids, you know, watching their migrations. It's amazing. 900,000 children are tracking the butterflies in America, the monarchs. Isn't that amazing? The kids know how beautiful this is. So anyway, this is a building I'm designing in Barcelona, and my decor for the lobby is 2 walls. So you come in, instead of ficus trees or something, you have 2 walls with shelves, and there are butterflies hatching in the walls. And then the outdoor is the casement windows indoors. So on the weekends, the children will come and release the butterflies into Barcelona. These are the ones that are going extinct. And then the children are all looking into like, what plants do the Parks Department want to have, and what kind of plants do we need in the highways for the butterflies, because it's their butterflies, you see? It's so important to get the children of all species talking to each other. How much fun is that? This building has different elevations depending on its orientation. I'm working on a little house for the super poor. I'm working with the chemical industry, and we're working on what we currently call waste as potentials for building materials. And I'm working with companies that are developing new business models, believe it or not. Yurtle is a sharing site, so you can share things with people if you have things you don't need. How many people need tents right now, you know? You can't share. ICO is a company collecting textiles and shoes, so we can repurpose all the molecules and give reasonable things to people who can share them, and we look at it. I'm actually working with Walmart on very serious packaging protocols for the future, because their private label business alone is $140 billion, and it can drive and change whole industries. I think it'll change the packaging industry. All they have to do is say, I want. And if it's principled behavior we're dealing with, this is very powerful transformation. So I've also joined with Waste Management and the other recycling companies in America. So I'm going to the dumpsters, and we're going to be designing up from the dumpsters, because I was looking at a package of vegan, certified organic, gluten-free kale chips the other day. And I was looking at the package. It was in a pouch, because pouches are the latest rage. And I was looking at the pouch. There's no recycling symbol on these pouches. There's 7 types of plastic. The inks are toxic. The coatings are toxic. The 7 layers are there for oxygen, for water, for printing, for stiffness, for shininess, for I don't know what. But these things are complete dross. We have nothing we can do with them. We can't reuse them. If we burn them, it's toxic. If we put them in landfills, it's a waste of all kinds of craziness. And so we're looking up from the dumpsters. And like the Tao says, you know, the master is like water. She seeks the lowest places others despise. We need to go to the dumpsters now, and we design up from there and say, you must be kidding. Look at what you're sending here. It's insane. And the modern cereal box, the inks from the newsprint that is used for the cereal box are migrating, and it's oil-based toxins, frankly, heavy metals everywhere, migrating through the HDPE package into the cereal itself. We have now found these dangerous materials, including carcinogens, in the cereal in measurable quantities. So are we going to give our children cancer with breakfast? Is that the plan? You see? It's time. And if we just reduce the packaging, is that going to do it? So this story is an important one, and I'm very pleased to let you know that Stanford, I have a professorship at the engineering school at Stanford, and Stanford has decided they're going to do the first living archive at the Stanford Libraries because they got Buckminster Fuller's archive, and they decided they wanted to look at the world of sustainability and the history of it. So they've asked me if I'll be the first person, and I get to look around, and everything I do is archived and filmed, even in my office, everything. And it'll all be available in the archive. It's pretty cool. So you can look at my schedule and say, oh, Bill met with today, and here's a speech he's giving at Dartmouth. It's on his calendar. There it is. And oh, I wonder what that was. And click, and there it is. It's fantastic. And so we're doing 1 degree of separation, so I'm picking my first 100 1 degree of separation people, and then we're just going to keep moving as we tell our stories. I also been engaged by the Chinese government. We have the license for the first private telecommunication channel for China, and I was asked to think about it, and I was given the content license with my partners. So now we're going to be the content providers for the children of China. We have 500 million customers, and we're going to be the content on all smartphones and tablets in China. And so the messages we're going to be developing, we're going to curate things from around the world. We've decided not to create content because with the children, we'll spend a lot of money creating the wrong content. So we're going to let the children of the world send us what they love, and we'll curate it, translate it into Chinese, Mongolian, Tibetan, various dialects, and then send it back to the children. And we'll give them education for free, like the Khan Academy. So I get to work with the Chinese government quite closely. This is Minister Wang Gong, Science and Technology, John Holdren, our Chief Scientist of the United States. And I represented the White House at the Innovation Dialogue in Beijing. I represented the private sector from the United States. So this is not an insignificant initiative. We are incipient and we're small, but we really care, and people are starting to pay attention. So, to finish, instead of just simply be less bad, I think it's time for redesign, to renew and regenerate in addition. And we need to do this together, and it's going to take us all, and it's going to take forever. But that's the point. Thank you very much.
Some questions. We'd ask you to keep any statements to a minimum and go ahead and ask your question to allow lots of others to ask questions. And I just want to point out that immediately after the Q&A, which will be 15 minutes, books are for sale from the Norwich bookstore. In particular, the Upcycle is for sale. And Bill has graciously agreed to sit down over there in a chair, and you can come on up and say hi if you want. And if you have a book, he'll be glad to sign it. So, questions, please.
Can you tell us a little bit more about the low-cost house or the hospital?
Yeah. When you look at Buckminster Fuller's partners sent me the model he was working on when he passed away, because I had been asked by his family to give his 100th birthday address at the Cathedral of St. John the Divine in New York. So they sent me the model he was working on when he died. And it was quite astonishing. And it's tensegrity. So we're past the geodesics. We're into what he took from Kenneth Snelson, the sculptor, the idea of continuous tension, discontinuous compression. So, but you couldn't build with that. It's sculpture. You know? But what I was thinking is, as Bill Clinton asked me if I would think about Haiti and help sometime when they stabilize a little bit. And so I've been thinking about it, and I started to realize that one of the assignments of modern culture could be, how could we build a dignified home for people in their own culture that's appropriate with materials at hand, where a house could be built by a family with their children in one day without tools? That took me 2 years to figure out that sentence. Anyway, so I started working on it, and I basically got some support from the chemical industry to help me think about it. And what we're looking at is taking each place and imagining how to help as quickly as possible in a way that works for each culture. So for the Haiti, for example, they have no materials at hand. It's devastated. And they need hundreds of thousands of homes. And you're dealing with the poorest country in the Western Hemisphere, right? So what are the materials at hand? And what we see are plastics in the refuse piles. What we see is the city of New York spending $85 a ton to ship plastics and materials to Ohio. And we start to realize we could take these things, and with these economics, we could start to make building materials that are generally available at a negative cost of goods. Negative cost of goods, because we have to get the price. You know, when you look at the aid houses that are being built in Haiti, they're $30,000 each. They're concrete. They have metal roofs, and they're at 7'8", which means they're an oven. The materials are toxic, which means they're gas chamber, and they're organized into these square blocks very tightly, which means they're a concentration camp. Concentration camp, oven, gas chamber, right? This should go to The Hague for a tribunal. You know what I mean? So, anyway, the idea would be, what could we do that's generosity, and how will we do it? So what we're looking at with the house is a series of things that can be assembled very easily, very light, fire retardant, safe, but use all these materials that we currently consider waste, and be able to make building materials that work with local culture, and that's what we're doing. And so each culture has a different response, depending on what the situation is. So even in Haiti, whatever we do right now with materials at hand, where people could do things, will probably morph as we grow various things that can become building materials that are local, for example. Because all sustainability in the end is local. So it moves toward that. So for the Indus River, you know, we're designing a roof system, because they can pile the mud and they don't have earthquakes, but they need roofing. They don't have tensile material, they don't have skins. So we can say we're going to focus there, and same with Mexico. They don't need help with the walls, they need help with the roof. So we can do things with roofing using these various materials and things like that. And so we're starting with the idea of negative cost of goods, and changing the question of capitalism from how much can I get for how little I give, which is the current relationship, to how much can I give for all that I get. So it becomes a question of scale, of mass production, and safe materials in an optimized system. That's what we're doing. I'm very excited about it. It's being, right now, we're working on it at Berkeley, and we think we'll try and connect it to the Dartmouth initiatives that were here, as well as stuff all over. We're going to help a lot of people as best we can.
So when creating these sustainable buildings,
Excuse me?
when creating sustainable buildings, what are some of the artistic elements or philosophies that you think about when designing?
Artistic. I think I always like to design buildings as if I have to deal with Fred Astaire and Ginger Rogers moving through the building. I think that's one of the favorite parts, is to think of it as choreography, and that it's a stage set for magnificent dancing. I find that helps. I think total beauty is important. I mean, we find, how could something be beautiful if it destroys children's health or the environment? There's that. I think that's also an aesthetic question as well. But in terms of form, you know, I'm designing a new carpet collection, and we're benefiting St. Jude's Hospital, which is cancer research for children. And I've got this design I'm working on. It's based on the butterfly wings. And it's a new design system that people can use. And what I've discovered, which I love, is that we have a saying in the stone business. If you go to Pietrosanto or Carrara to look at the marbles, the stone cutters will take their big sponges and they'll wipe down a slab that looks like concrete, and you'll see Technicolor marble, or like unbelievable. And what they say, it's so beautiful. When you go, oh, they go, God never had a bad day. Yeah. And what we found is that if you work with these things that come from the natural world, they're inherently beautiful. We find that really amazing, aesthetically too. That's why architects like proportioning and harmonic proportions, because Fibonacci and these things are actually really, part of, sunflower grows that way. Our brain sees that. We see that. We know. It's a beautiful thing.
So all energy requires sacrifice. That's what we're told. Can you speak to clean energy and give us some hope?
Well, I can. Yeah. The question is, all energy requires sacrifice, and could I talk to clean energy and give us some hope? Well, that's the, that is, for many, the 800-pound gorilla. There is hope, I think. We're seeing in the renewables sector, obviously, solar photovoltaics have collapsed in price due to commoditization, with lots of market disruptions around where they come from and how they cost, and tariffs and dumping and all the rest of it. But just on the bottom line, photovoltaics are now at 80 cents a watt as an object. And so it's really a balance of system we're dealing with in terms of cost variables. So solar collectors are now in many places cost effective. Just there it is. And so that'll come, pretty dramatically. It's really funny when you see articles in the New York Times that the utilities are upset that people are putting solar collectors on their roofs because it's becoming so dramatic that it might affect their business to the extent that they have to essentially, by giving benefit to those people, they are having to charge their other customers for the transmission systems that these people don't need all of a sudden, and the balancing gets strange. But I think we can work that out. That's a PUC issue, and it'll play itself out because the money will drive it. And I think the utilities will wake up one morning and go, maybe we should get into that business if people want this, So I think we'll see that. We're already seeing it in some of the utilities that are co-ops or munis. They're already doing it because they believe in their customers and signals from the marketplace that they'll respond to that. So there's that kind of thing. I think on the wind power, for example, which is very cost effective in many circumstances, it'll probably migrate off to the big stuff in the Midwest where the farmers get a lot of benefit from it. And it works in the landscape, and then offshore and things like that. So I think we'll start to see that. We're seeing that in China already, because we're looking at Shaanxi province where the coal comes from, west of Beijing. Massive wind resource, but they can't get it to the city, so because of the grids and so on. So we're just saying, well, wait a minute. What we've discovered in Silicon Valley, but mainly in the Netherlands, is we can now grow strawberries using 2 reds, near red, infrared, and 3 blues, and we can grow in the dark, because most of these plants are actually frequency selective and they don't really need white light. So we can actually, I started looking at this for the Baltic because we're trying to figure out how to grow food in midnight darkness in the winter there. And wind, LEDs, gallium, indium, LEDs, we can grow in the dark from wind at night. And the plants don't really care if you hit them at 2 in the morning with a big one, they're happy. So strawberries in the dark, huh? So when you think about it, we could take that giant wind resource, which causes all the dust from the lowest plains toward Beijing. We could actually use that wind energy where they harvest the coal and use the trains that they had for taking the coal to the city to pollute, could take food to the city. So we use the train and we wind power the food. And the food goes to the city, and then we bring back the phosphates, the nitrogen, because we don't believe in sewage treatment. We believe in nutrient management. So we've got systems now to take phosphate and nitrogen out of sewage. And so we treat it as fertilizer. So we say make fertilizer factories, not sewage treatment. And that removes the eutrophication of local water courses, and it reduces point source pollution. But it also gives the farmer slow release fertilizer, which means we don't have non-point source pollution when it rains. So all of a sudden it rationalized the whole thing, and the city becomes fertilizer factory again. See, born in Tokyo, I grew up listening to farmers in the middle of the night come collect our sewage. And my mother would sing us songs about the honey wagons and the night soil. I always thought the city and the farms are one organism. Still do. So anyway, we're starting to see that kind of thing. Pretty exciting. But I'd say the one that's going to sound really eccentric, and I'll warn you, this is very eccentric, is we are starting to see academic, peer-reviewed documentation that low-energy nuclear reactions are actually happening and being documented. This is quite astonishing. So we're seeing energy sources where one energy unit goes in and, up to 10 come out with very low energy reactions. Quite amazing. So that's something worth watching. It's a bit odd because it's got another name which is called fusion, and when you mention that, everybody runs. As I can understand, because in 1984 that was a pretty dramatic blooper. Right? Non-repeatable experiment. That's not a good way to start in a technology area. But we're starting to see it at Berkeley, we're seeing it in Bologna, and we're seeing it even in some of the federal laboratories. So.
Do you have thought about housing for the poorest or not?
Yeah, that's what Make It Right's about. That's why we're trying to do this thing with New Orleans and wherever. And these are very affordable buildings that, are where the materials are as safe as we can make them. Now, the ones we're doing in New Orleans are really, very particular, and they're experimental, they're high architecture kinds of things, so we can test. It's really a test bed. But we've learned a lot that could really help a lot of people. So we just built a project in Newark, New Jersey, and we're doing another one in Kansas City. And we're about to do one at the Fort Peck Indian Reservation in Montana. But for me, they're all still sort of, they're just doing the best of conventional technique because it's still early days in this area. But I think the Wonder House project is going to be a breakthrough here. I hope so. Because I'm looking at a house, in the case of Haiti, $5,000 a house, a dignified house. And because of the use of mass production. And the model I'm using, and the reason I think this isn't totally insane, is, has there anybody here heard of Aravind hospitals in India? Anybody? Yeah. So, yeah, there was one of my great heroes, a doctor named Venkataswamy, and he was a cataract surgeon. And one day he just woke up and he went, wait a minute, this takes 10 minutes. I need a scalpel, one nurse. I mean, it's a non-infectious disease. I don't need air conditioning, So why is this $1,900, right? And he said, I could just do a surgery, clean up, turn around, do another one. So we could have gurneys like that. And if we can make cars with mass production and hamburgers for 50 cents, goodness, if we can do all that with mass production and collapse prices, what if we mass produced health? Things like this. I can do this. It's 10 minutes. So he basically decided his economic model would be, if you can't afford it, it'll be free. And if you can't afford it, it'll be whatever it costs to finance the whole system. So the top end, who can afford anything, will pay for the whole system. If you can't afford it, you get it for free. He's a doctor. Beautiful. So he decided to do this. And it was really hard at the beginning. He had buses, and he would go to these villages, and there'd be these women sitting by the side of the road, 80 years old with cataracts, who couldn't see. And he'd say, well, you and your person taking care of you is two people that are, not celebrating life. And, would you like me to give back your eyesight? And they'd go, huh? And he goes, yeah, it's free. You just get on the bus. I mean, this is biblical. Right? So it's like, there. And they would all go, what do you want, my kidneys? They were all very suspicious at the beginning. Imagine how hard this is. Anyway, this is the magic of generosity, right? And so, anyway, they got on the bus, and finally, the point was, When he died 4 years ago, he had given eyesight to 2 million people for free. 2 million people for free. He had 7 hospitals. And if you could afford it, and you could afford anything, the highest price necessary to pay to finance 7 hospitals full of doctors giving free cataract surgery to those people who have nothing was $190. Of course. So you see, this is mass production's finest moment. That's what it's for. And it's a benefit. So he was being very efficient while he was doing the right thing. Isn't that beautiful? And if he wanted to be a millionaire, all he had to do was say, it's $250. You know, right? That is amazing. So I want to apply that to housing. So I want the children to be able to go on cell phones in Haiti and play a game like they do now, Minecraft or something, and play a little game, which is the Wonder House game. And they can say what they need for a home and play with all the parts and build their little thing out of our parts. And then they hit send, and some little kid in Scarsdale, who's about to get a BMW for their 16th birthday, is playing the game with them and goes, hey, Mom, Dad, can we give somebody a house for $3,000? I'll get a used BMW. Send. The game. One more?
Yeah, one more question.
Do you think that the political will is helpful or destructive in the goals that you're trying to
Political will?
Political world.
World is helpful or destructive? I don't know. I think it's confused. Yeah. I think it's confused. Well, I think it's so hard these days to align people. I mean, if you look at, just the politics of the United States, it's very awkward. I mean, there's all kinds of strange interests. You can't really do something simple anymore. You've got carve-outs and special interests everywhere. So it's very hard for everybody to come together and celebrate something. That's why I think we have to do it by design, and we have to use commerce as the engine of change. Because I think if we get down to the core of it and we do things that are cost-effective and better and make people money and go in this direction, then we can move in that direction. And the reason I work with China is that because of the way we can structure our deals in venture and the innovation, which I'm working on with them and others, is that, see, if you look at this moving from sewage treatment to nutrient management, the reason I do it with the Chinese is that I'm getting the Chinese are making the investments. It's the government that I have as a venture partner in this, right? So we invest in these technologies. Once we figure out how to do it, and it turns out it's producing about 12% return to take phosphate out of sewage instead of, you can sell it for 12% money. So now the city can make 12% off of what used to be a liability and a cost is now a revenue generator, and they make fertilizer. Interesting. So you see, once the Chinese have invested in that, the interesting about China is that the investor then is the customer. See, so if you want velocity and scale, why not have the investor going, wow, that was cool. What if we ask all our cities to do this? Oh, see? And then we get to use it because they figured out how to collapse the price because they're doing a lot of it in a hurry, and we all need it. But if we get technology that we can deploy here or copy or do whatever, well, then we get the benefit, and the inherent part of sustainable technology is that it's inherently local. So the Chinese are not going to capture our sewage, I promise you. You know what I mean? They don't want it, right? So great, that's sharing is good, see? Because it's inherently local. All these things inherently benefit the local. Even a solar collector coming from China, we need trade fairness and we need all the rest of it. But even that, I mean, a collector that comes at 80 cents and works really well, and we figure out how to renewably power the whole system, which is the point, is a benefit to somebody locally, somewhere, because they're capturing local solar income. The Chinese will never, I promise you, capture an American photon. Not going to happen, okay? They can send us something to help us capture our own photons, but those are inherently local photons, right? Rock and roll. Thank you very much.
On that note, thank you, Bill.